So hello everybody, my name is Josef Habdank and I'm Principal Solution Architect at Lux of DXC, and I'll be talking about the management of Cloud Data Lake in practice. So basically, how can you scale the data lake management into thousands of ETLs using Apache Spark? So I assume that everybody in the conference knows at least a little bit about Apache Spark, so I'm not going into details about it. But briefly, it's an extremely efficient framework to connect together big data components. It's a processing framework that basically allows you to read from a variety of databases, write into the variety of databases, create a very complicated pipelines to transform the data and do machine learning. However, Spark has its strengths and its weaknesses. It's not all rainbows and unicorns. It's not everything is perfect about it. So the good thing about Spark is that it can work with large variety of technologies, and it's extremely scalable when you throw it in more data, right? So basically, if you use Spark, you generally will not have a problem, generally, of course. If you suddenly scale 5x or 10x, it's gonna be able to swallow that and you will not have problems with that. However, and it's very flexible in creation of very complex transformations. So that's why it's so powerful for machine learning, is because it can do very complex data transformations, way more complex than traditional SQL can do, and therefore you can actually use it for machine learning, right? These are its strengths. However, it has its weaknesses, and one, if you start using it, you need to be aware of them in order not to fall into a pit of them. So first problem that it has is that it has a very weak support for data governance, and it has only few security features, right? So basically, if you start using it for a generalized data lake for your entire enterprise, you need to address these things. And the other thing that I'll be actually talking mainly about is it has very weak support for orchestration when you're dealing with thousands of ETLs, right? So it's very good when you make very complicated ETL, and that pushes through, many gigabytes or terabytes or even petabytes of data. It's going to work very, very well. But if you suddenly have, let's say, hundreds or thousands of ETLs which are similar and has only small differences, let's say this table, makes this select statement, this table makes this select statement, but actually overall landscape across those all transformations is the same, you will have very hard time actually managing that using native Spark without applying additional layers on top of that, right? And that ties back to my last point, which you can see on the right-hand side, is that if you have many jobs which are very similar, just have small differences, it lacks templating tools to basically replicate similar functionality across and only change small points. Of course, you can do this manually using software development best practices, but these things are not built into the framework, and that's something that you have to be aware of. So why data lake management is critical from day one? Well, basically, when you start a new project or you join a new enterprise, or maybe you deploy a new data lake for existing enterprise, you start with a couple of ETLs, and your ETL landscape, your data lake, looks more like something that you see on the left-hand side, right? You have maybe 10, 15, 20 ETLs, not a big deal. You're orchestrating it very easily. If something crashes, you exactly know where the problem is because there's so few jobs. You just, from the name of it or whatever, you right away know what the problem is, and you have no problems generally, right? Spark in that early stages in the native Spark with no additional things on top works extremely well. However, without knowing, you will turn your data lake landscape will turn to something what you see on the right-hand side, and that's actually a real picture that I took from the ETL map of one of our customers, with his permission, of course, to show you guys. I mean, the transition from what you see on the left-hand side to what you see on the right-hand side is extremely quick, and it will sneak up on you. And if you have the mess, like the complete craziness of interconnected ETLs flying left and right, and data flowing continuously and being mixed, joined, and transformed all the time, like you see on the right-hand side, you will basically be completely lost without any additional tools. And so that is what the problem is. The problem is you need to be able to manage that chaos of data lake that is actually a day-to-day experience if you go to a slightly larger scale. So if you just design for the thing on the left, you will actually get to the right, but you will have huge technical debt without actually knowing it, because things will become unmaintainable. You will not be able to control your data lake without having additional tools that if it's on the size on the right hand side. And that, by the way, is not, when I say size, I don't mean petabytes or terabytes. I mean number of ETLs and number of data sets that you're dealing with, and number of the complexity from in a parallel processing perspective, and not in 10 machines, but 10 different ETLs, 100 different ETLs, or thousands of different ETLs. That's the complexity I'm talking about, not the volume, because volume Spark takes care of very well often. Generally, you don't, unless you make mistakes, you don't have a problem with that. So whenever you're thinking of deploying a large-scale data lake, you should think of data platform management tools and areas. And for the sake of this presentation, I outline 8 areas, and I'll cover only a few of those, by the way, in this talk. So you need to have some sort of data set, data catalog, and data flow tracking, so lineage, to know basically how the data flows through your system and how it's being transformed and evolves as it goes to different layers in your data lake. Then you should have some sort of tool to automatically deploy ETLs. So either so that's data flow generation. So either code generation, or basically have some sort of component, some sort of engine that executes ETLs by providing it some configuration files. Of course, you need to have infrastructure as a code deployment, so you don't have to do, you can manage the environment very, very well. Then you need to have some sort of execution monitoring to see which ETLs are failing or not. And the thing that actually many people forget, which I think is perhaps one of the most important parts, is data set and data flow monitoring, which some people call technical and functional reconciliation, which basically means some sort of quality assurance as a proof that the data is actually not being lost or corrupted on the way. And I have a slide on this later. Because there is this, in Germany, there's this saying of watermelon systems, where it's green on the outside but red on the inside, which basically means you have failures without knowing that there are failures, and that element tackles this. And then you need some sort of anomaly detection. So if you have actually, you're correcting your metrics on the system of how it performs, exceptions, data loss, rows, issues, things like this. Of course, those metrics then require some sort of anomaly detection in order to trigger action. And once there is an anomaly detected, you need some sort of automated enterprise workflow that actually does certain things if you detect the error, right? So the framework that we've built at DXC, lots of DXC, and that I'm going to talk about here covers only these areas, right? So it doesn't cover everything, but covers a lot. And it was done using Spark, and I'll tell you briefly, of course, not in the very detail because there's not enough time, how we actually did it and why this is actually as clever as I think it is. So the problems that you'll be dealing with when you grow in scale, again, when I say scale, I don't mean terabytes to petabytes, I mean from tens to thousands of ETLs. That's what I mean scale in this case. Is data governance and data discoverability, support for multi-tenancy, how to structure your work and your talent management so that you don't have you don't need ultra talented people to actually work on your framework, so you can actually have more junior people actually still contributing. And then efficient orchestration. Again, if you have thousands of ETLs and they're all interconnected, you cannot just have simple orchestration to actually manage that. And then quality assurance and data reconciliation frameworks. So now let's go through one by one how we tackle this in the framework that we built using Apache Spark. So first thing is data governance. So for those of you who don't know what is data catalog and lineage catalog, I mentioned it briefly. It's basically a database that consists of, that has information on what data you have. And that means metadata, meaning schema, meaning what kind of tables you have, what kind of columns there are inside, how this table evolved over time. So what are the different versions of this table? How does it look like how did it look 1 year ago? How does it look right now? As well as preferably some additional business metadata, like who's the owner of this, what's the business meaning of this data, what are the policies around this data, security policies, data freshness policy, things like this. So define your data set and your lineage, so how these things interconnect in your data lake, and basically have this as a searchable and browsable database that people can use to discover data that you have, right? And there's plenty of both open source or enterprise tools that can do that. And we don't have any preference on which one to use. What we did, however, is we made a small layer designed by us, a small kind of a small repository that our Spark infrastructure interacts with, which has the lineage and the data catalog, which is only designed for this framework, which then is connected to the bigger data governance tools, right? So we made a kind of buffer layer, which is designed specifically for our ETL framework, that then can be easily integrated with Erwin, Apache Atlas, Elation, Azure Purview, or whatever else you're going to be using, right? So what I recommend, if and what we did inside is you build an abstraction layer, right? Build an abstraction layer so you don't bind yourself and your core framework that you're building for managing of ETLs with specific tool for data catalog for your data cataloging, right? Make an abstraction layer that you work with, and then have it interact through abstraction layer with the main data catalog. So then the other thing is support of multi-tenancy. That's a critical thing, because what the problem is? The problem is that you might have very high cost of redeployment across environments or multiple tenants. When I say multiple tenants, I mean environments. I think everybody knows what it is. Like it's dev environment, test environment, pre-production, or production environment, right? So you want to be able to smoothly move between those two with absolute minimum amount of work when you have deployed something on dev to move it to test or whatever else. So that's obvious. I think everybody knows this. But multi-tenancy as well means if your organization is larger and has actually multiple IT infrastructures, right? You want to be able to seamlessly move between those. Let's say your company actually consists of 5 different companies that were bought up over time. You want to be able to move, have one system to manage all those, right? So that's why actually multiple tenancy and multiple environments is effectively the same thing, because what happens is that you want to be able to easily deploy basically on different environments. If it's dev, test, or prod, or a different company within the same enterprise, different IT infrastructure, right? So typically how this is done is using DevOps, right? You have a component that is configurable a little bit, and then in your DevOps pipelines you start switching those the resource names that it's interacting with. So right now it's dev, and then you move to test. So you actually switch the database from dev to test database, right? That's the typical way to do it. What we did in our Apache Spark framework, actually, that we deployed internally, is we actually went one step further. We actually built a resource abstraction layer that is switched from environment to environment. So you don't have to actually change the configuration files when you of the component, because the component talks through resource abstraction layer to the specific resources. So we actually configure, let's say you have ETL moving some data set from raw layer into staging area, right? So normally what you would do is say, this is the raw layer, this is the staging area, these are the specific pointers, databases, or to locations, run the ETL, go for it, right? And then if you move it to test, you would switch those pointers. What we're doing is we're not doing that. We actually have fixed, we're actually saying, you're gonna be talking with this abstract database, and you'll be moving the data to this abstract destination. And underneath it, we have a resource abstraction layer, which basically redirects the traffic to the right place. And there's a really, really good reason for doing that way. This means that the DevOps guy who's gonna be working on a new environment doesn't have to understand all the components that are there. He just rewrites the abstraction layer. He just says everything, all the database that is called raw, point here. All that the database is called, let's say, modeled layer, point there. He doesn't actually have to understand if there's 50 ETLs or 3 ETLs. He doesn't care about these things. ETLs are defined on above the abstraction layer, which means they point into abstract pointers. And if there's 3 or there's 100, it doesn't really matter. And then the DevOps guy who's gonna make a new environment, he just cares about the resources that are being interacted with, not about the actual components. And that's maybe a subtle difference, but it makes a huge difference in the next topic I'm going to discuss, which is separation of engineering concerns and talent management. Another problem you'll be dealing with is if you're working with complex data lakes, you will tend to have tasks which are very multidisciplinary. And that means you will need those unicorn style engineers who knows everything, who knows the data modeling, who knows the data governance, who knows the engineering aspects, who knows the SQL, who knows the DevOps stuff, because the things become so intertwined easily that you're not able to actually have more junior people who know only their narrow areas to work together. You need one guy who knows everything, to do everything. And those people, of course, not exist, but they almost don't exist. You maybe have one like this in the whole department if you're lucky, right? So you need to structure your work such that you can have more junior people to work together. So when we deployed this framework, we actually on purposely designed it so that 3 different types of talent can collaborate together. And what that means is you have a person who understands the data, so data shepherd, data modeler. He cares about schemas and lineage. So what table connects with which, and schemas. So he only defines these parts in the system. So he works only with schemas and lineage and defines it as a config files and doesn't care how the data is being moved within. He just cares about the data flow in general. Then you have SQL engineer who doesn't have to have the overview vision of the system. He only cares about, this is my input, this is my output. How do I write SQL to make this transformation? He doesn't care about anything else. Again, he can be junior guy. He doesn't have to understand the overall landscape of the data lake. He only cares about writing SQL with narrow requirements. And then you have the data platform engineer. Again, he doesn't have to understand the intricacies of all the ETLs and how things connect, and if this is 5 ETLs or 20 ETLs or 1,000 ETLs. He only writes this data abstraction layer. So he knows, okay, the overall data lake is interacting with these 20 resources. I only have to write a config file that maps my abstract locations to those 20 resources. And I don't care if there's 1,000 ETLs, there's only 20 resources. Right? So we divided in this framework, and if you would be doing a similar thing, I recommend you to do this as well. Divided our system into 3 different separate areas, which you configure separately. And each of people working, they think narrowly about their area. I only think about this, my small thing that I'm caring of. And that's data shepherd cares about data models and lineage, meaning how they connect. SQL engineer, how do I actually transform my step A to step B in the transformation? And data engineer about how do I map my 20 resources I have in abstract layer into 20 physical resources, right? And then these 3 things put together, they connect nicely, but people don't have to think about what is beyond my narrow scope of view, and that allows you to use more junior people to actually deploy very advanced system. The next thing is data efficient orchestration. So if you recall the image I had on the beginning of presentation with this, 1,000 ETL landscape, there is absolutely no way it can be orchestrated using traditional methods, meaning trigger this ETL at 7, the next ETL at 7:30, next ETL at 8, next ETL at 8:30, and have the data flow like this through the system. Basically, it's impossible. I mean, the complexity of flow becomes so large that it's completely unmanageable. So the key thing in the framework that that we built is that it's self-orchestrating because it's event-driven. And when I say event-driven, I mean that every single data set is being observed, and if there is a bulk transaction submitted to a data set, it emits a message, I've been updated, right? So I mean, I say updated, I mean, there were some changes in me. So either insert, update, delete, merge, whatever else is happening. When this message is being emitted, the system automatically checks what data sets, what ETLs are connected in the lineage that are reading from this data set. Because we have lineage in our config files, we can simply find out, okay, this data set table 5 is updated, I don't know, customer database. Let's check what ETLs are reading from this, because lineage is explicitly stated and each ETL is explicitly declared. You can automatically see these 5 ETLs are depending on the customer table. So let's trigger those because there is an activity on the data set that they depend on. So then they read the data, they get triggered in parallel, they read the data, they do their processing, they write the results somewhere, and as soon as they write the results and the transaction is closed, these data sets are emitting an event saying, I've been modified. And again, the same thing processes. The same thing repeats. So basically, if there's more ETLs down the flow, they'll be automatically triggered in a sequence. As soon as the transaction is committed, it will trigger a new event, and it's gonna run the processing. By the way, this is using Apache Spark. So this is not a trivial actually to do because Spark typically don't work in transactions, right? So actually we did some tricks in order to do that. We're using signaling files, we're parsing the success files, things like this. We're doing a number of things to actually detect those events, but it's fully self-orchestrating. And the good thing is that if you have such a design that is fully event-driven, you do not have to actually orchestrated manually from the high level, meaning how you would normally do it in a traditional systems when you start triggering things sequentially by time. Everything just happens magically because you run ETL, it performs the ETL, it summons the transaction, creates the message saying I'm done. This data set is finished updating, and then automatically everything else that is behind it will be automatically triggered because everything is event driven, right? So you don't have to actually ever have this overall orchestration of the data lake because it's self-orchestrating organically based on events. And then the last subject I want to discuss in detail is the quality assurance and reconciliation. So the problem, as I mentioned before, is that the biggest issue on the data lakes that I worked with, and I worked with many companies and many data lakes, is that people don't actually look at quality. They only care about monitoring. So people say, is my ETL running or not? Thumbs up. No exception. Everything is good. So no problem, right? And there's this kind of very shallow monitoring philosophy applied, and that is basically unacceptable because this is not going to work. Because you often have ETL succeeding, but some data is lost either because query is wrong, some table that you're joining with is missing, so your join suddenly it doesn't work, and you start removing data if it's inner join, or other things or maybe if it's outer join, you don't have the data and you start getting null values, and so the data can get corrupt as it goes through your flow. But you kind of just look, did my ETL run green yes, red no, or there was exception red. You actually have to look at the data itself and understand it if it actually has what the customer expects. When I say customer, I mean the people who are using the data at the reporting layer, right? So there are normally, when you think about this, there are two types of reconciliation. When I say reconciliation, I mean is the data as it should be, right? So there's technical reconciliation and functional reconciliation. Technical reconciliation means that you can prove to yourself that no data was lost, but it doesn't understand the data at all. It just says I had 1,000 rows on an input, and my ETL chain that has maybe 10 ETLs, there was 1,000, whatever transformations you do. Of course, up to the point when you start grouping, then you cannot just look at row counts naively like this. But generally, you are verifying to yourself that on the technical level, on the just row count level, that the data was not lost, and that is extremely important to do. Because it's a very early warning system, because you do it in each ETL. In Spark, we use accumulators, which are extremely efficient with actually row counts. You actually see very early if you lost some data, you can immediately react to it, right? You don't find out on the end when the reporting is already happening and somebody complains to you. You find very early in the flow. Okay, 1,000 rows was on the first table, and then there's 999 in the next one. That means I lost one row. That means there's an issue. Right? So technical reconciliation just checks row counts if you have actually went with the flow end to end. The functional reconciliation does something different. It actually looks at the content of the data and compares the data as early as possible, so on a source, with the data at the latest point, which is the reporting layer or some sort of input to machine learning or whatever consumption you're doing of this data on the other side, right? What you would do is you would generate some sort of KPI report or some sort of query. Let's say, to give an example, what is the daily sale per shop, per product category, and what's the total sale in euros, let's say, right? So you generate this kind of early report on the source, simply query, select, sales, category, shop, date, in group by, of course, category, shop, and date, right? So you make this very simple report on the source, and then you make a similar report on the very destination, which of course is different because there's different table structure, but you want to produce the same structure and you compare those two reports. So you create one report, let's say sales per day, per customer, per category. You create the same report on the end of the flow, and those two reports have to be identical. And in that way, you verify that you have not corrupted the data on the way. One of the biggest mistakes that I see happening in the data lakes is that, for example, the label was flipped. Let's say category was switched. So the total number of rows is correct, right? Your technical reconciliation would not fail. But because of some issue, let's say you're slowly changing dimensions or something like that, you actually have an issue that you flip the label on a row, and your whole reporting is messed up. Not because the data is lost, but is miscategorized on the reporting. And therefore, you have to have this functional reconciliation where you actually have deeper dive into the data and compare the data on the slightly deeper level using some sort of query on the source and destination to verify that this is actually that you deliver the data as it is expected. All right, so I have one slide on implementation. I don't have more. I could talk about, if I go into the implementation of Spark into the very detail, I would talk for 2 hours, right? So nobody has time for that. But I have one slide on the actual implementation, what kind of tricks we did to make this using Spark. And there were some very powerful things we did, right? So data catalog abstraction, for example, Spark has already a built-in JSON schema export functionality. So we use that one to actually build the catalog abstraction. We simply export all the data sets, the data frames that we have in Spark ever into JSON schema, which is stored as a JSON, and that's our abstraction that we can later export to other catalogs. Lineage as well. We build our own config files that basically that allowed Spark to point into right locations when you're doing the transformation. Then we're running those details on Spark SQL. So we have actually a repository of Spark SQL queries that we're using. So when you're basically building a new ETL, you say, I'm gonna pick these 2 tables from the catalog. It's gonna connect like this, that's from Lineage, and it's gonna run this SQL query from Spark SQL repository, right? So, and then it just executes this query. Resource abstraction layer is done again quite simply. We simply dynamically mount and unmount blob storages into the framework, which is and when you're dealing with the blob storage style data. If you're dealing with tables, you simply can register temporary tables in Spark. Again, the same thing. So you have dynamic registration of tables or dynamic registration of mounts in order to build those resource abstraction layer. And then on quality assurance, we're using accumulators. Again, another tidbit for advanced Spark users here who are listening to this. If you want to do statistics generation on Spark, try to use accumulators because they will do it free, meaning you not pay any extra computation power, or you pay extremely little extra computation power to actually collect statistics when you're processing the data. And then you will be able to actually use this. Another trick we did actually was to we parse the Delta Lake transaction log. When I say Delta Lake, I mean the Databricks storing format, which is Spark here with some additional transaction logs. So actually dynamically parsing the transaction logs of Delta Lakes to get what kind of activities were happening on this data set and start triggering events or collect statistics. So that was pretty much it what I had. So small summary. Apache Spark is an extremely powerful tool. I have been working with this for many, many years, since version 0.6 or something like that, and it's extremely useful. However, it's missing a lot of features which are related to data management. And luckily, Spark is designed to be able to make it easy to design those tools, and that's what we did in this framework that I spoke of. But you should not ignore this. If you're deploying a new data lake or you're going for a new project, think about these things early, because it's very quickly when you go from 20 ETLs to 200 ETLs, and the technical debt you're gonna take with, if you don't think of the data management, will be incredible, and it's gonna simply destroy your development in the future, because you'll be paying so much interest on the debt that you took. Last thing, if you want to work with the amazing projects in Apache Spark on Azure, we're hiring. If you want to work with me or projects like this that we're working with, I mean, building frameworks like that, the one that we built, or with the cool projects when you're dealing with massive enterprise problems, come and work for us. I don't want to spend too much about this, but simply write to the email that you can see. You can ask for me, and I'm Josef Habdank, and they'll tell you which projects to apply to. We have openings pretty much for every type of engineering talent that we need. And with that, maybe you can spend a minute or two on question or answers, or reach out to me on LinkedIn or Twitter or whatever else. With that, thank you very much. Bye.